Okay, Assalamualaikum and good day. See you again in the next video. This video, I'll show you how to solve a problem related to the eccentric loading, which is eccentric loading is about the force, axial force is not parallel to the center of column. So this is question for example 2. The tube is made of copper and has an outer diameter of 35 mm and a wall thickness of 7 mm. So that's mean you have this is outer diameter 35 mm diameter and the thickness 7 mm. Okay. Using a factor of safety Fs 2.5, determine the allowable eccentric load. The tube is pin supported at its end. Okay. Before we start, let me highlight the important information that given from this question. Diameter 35 mm, thickness 7 mm, factor of safety 2.5. Okay, the tube is pin supported at its end. Pin support. Okay, and then the ECU. Okay, modulus of elasticity for copper 120 gigapascal and yield stress 750 megapascal. So for the first step, you have to determine the section properties of this copper tube. The first one, you have to determine what is the cross section area for this tube. Okay, you can get this moment of inertia. Okay, and r equal to square root of I divided by A, and this is the equivalent length. Equivalent length equal to K times L. K is referred to, there are 4 types of condition. Okay, for example, for this question is asking you about pin support, so that's mean both pin, so K equal to 1. Okay, that's third condition from the previous video. Okay, so LE equivalent length equal to 1 times 2. 2 is this length. Okay, 1 times 2, so equivalent length equal to 2 mm. After that, you have to identify whether this tube, this copper tube, will be failed due to buckling or not. Refer to the Euler formula. Pmax equal to pi square EI over LE square. So just substitute all the information and then you can get E, and this is I, and this is LE. Okay, this LE. So you can get the Pmax or P critical for this copper tube is about 18.98 kilonewton. Okay, so in order to know that is will be failed due to buckling or not, so you have to check with the yield stress. The critical stress, okay, should be less than critical yield stress. So from this formula, so you can get the critical stress is just about 30.83 megapascal. So it's less than yield stress. Yield stress is about 750 megapascal. Okay, so you get is very small compared to the yield stress. So this copper tube safe for this buckling criteria. For the third steps, you have to identify again for yielding criteria, which is you have to apply the second formula. Second formula is given with this equation. Okay, sigma max equal to P max over A and so on. Okay, just substitute all the information given. Okay, sigma max is sigma yield. Okay, sigma yield, and P max you have to determine it. So P max is unknown parameters, okay, and then A, and then just substitute everything, okay, except Pmax. This is Pmax. However, you cannot do simply solve this equation, okay, simultaneously. So you have to use your calculator to determine what is Pmax from this formula. So how to know it? You have to look at this video. Change mode to radian. Write equation using alpha mode. Change second to cos. Insert value for f, trial and error. Finally, after you get what is Pmax, Pmax is about 16.885 kilonewton. So it's below than sigma yield. So okay, it's below than from the buckling criteria, which is 30.83 megapascal. Okay, so that's mean this condition, this copper tube is safe for both criteria, for buckling and yielding. So you can get two value of allowable eccentric load P, okay, for buckling, one for buckling and second for yielding. Okay, for buckling you get 18.98 kilonewton, and for yielding you get 16.885 kilonewton. So you have to check from both method. Okay, you have to choose the lower one, which is buckling 18, Pmax 16. So you have to take Pmax for yielding as your condition before you calculate what is the P allowable for this question. So you just substitute Pmax here, 16.885 kilonewton, divided by factor of safety. You can get the critical, the allowable force for this question, which is 6.75 kilonewton. Before we finish this video, I just to remind again that in a second formula, there are some parameters that you need to know, which is sigma max, or you know, maximum elastic stress. Okay, P is referred to vertical load applied to the column when P less than vertical force. Okay, so E is eccentricity of the load. So that's mean if P here, so when this P move to the other side with distance, and distance we call as E, eccentricity of the load P. Okay, this is P. So the E is referred to the distance of P. Okay, so C distance from the centroidal axis to the outer fiber of the column. So the maximum distance, for example, if the force itself is here, okay, so the distance should be here. This is your C. Okay, what happen if your force P located at here? So the C is half of this width. Okay, you have to clear about this. Okay. A is cross-sectional area. Okay, everybody know about it. Okay, L is supported length of the column. The length of column like this. So this is L. Okay, E is modulus of elasticity, and R is radius of gyration. If you don't know, you need to use this formula. R equal to square root of I divided by A, where I is calculated about the centroidal or bending axis. So you need to clear about these parameters. Okay, this is for eccentric loading. The question example 2 that I given just now, you need to calculate by yourself what is the area, what is the C, R, and so on. However, if the question asks you, okay, the column that you use is based on this type of column. Okay, for example, this is W P 410 times 85. Okay, so you have to refer to the table. Okay, the table will be given in your test, in your exam, if this question asks you. Okay, we need to refer to the table W 410 times 85. So you just to check the table. Okay, is here 85. So here, okay, this one. Just underline all the parameters. So from here, you know the area of this column is about 10,800 millimeter square. Okay, and the width of flange. Okay, if you want to calculate how much the C, okay, C equal to BF over 2. Okay, so you just take it. This is on y axis, on y axis, because this is BF, so divide by 2, so C only this one, C. Okay, this is your C. Okay, take 181 divide by 2. Okay, this is the web thickness, this web thickness, this depth. Okay, whatever. Okay, this is for x-axis axis, already calculated for you. I equal to 315 10 power of 6 millimeter power 4. Okay, and this is for S. Maybe we don't use these parameters. Okay, no problem. So if y axis, you need to use 18 10 power of 6. And R already calculated for you, 40.8, and 171 millimeter. So you have to identify whether that question asks you about YY axis or XX axis. So from there you can identify what kind of parameters that you want to use for the question. So this is for already given in the test. This question is only if the question asks you to find what is the geometric parameters for this type of column. Okay, this specific column. Okay, I think that's all for this chapter. So good luck for your examination and see you again the next time. Thank you.